Hello, everyone. This is Lab 3 Magnetic Field of a Bar Magnet. I'm Devin Head. I'm going to go right to it. The introduction is in this experiment, we measure the distance dependence of the magnetic field due to a small bar magnet. And we use calculations from the Biot-Savart law to create a computational model and calculate the results of our experiment. And for this experiment, the results were 3.22 ampères squared for the magnetic dipole moment of my magnet, an N value of 3 from the Excel data, and the off-axis field at a 45-degree angle is 1.64 e negative 5, 1.77 e negative 5, 0. The concepts we're going to be using in this lab are magnetic fields in the Biot-Savart law, the magnetic field of a bar magnet, concept of superposition, the two included equations, and the K constant. We could ignore the Earth's magnetic field in this lab by orienting our phones to have a x component of 0 before the magnet was brought in as part of the procedure, and then using a meter stick to measure different distance values with our phone. And we could graph those values and the b values to find a linear equation for the graphed values, and then we could use that to find the n value in the magnetic dipole. These are the results from the Excel and finding the dipoles, and the results continued. We have our equation right there that we found from the data and our n value, and we have the magnetic dipole moment of 3.22 and the off-axis field that we got from those calculations. And this is the Glow script code included right here, where we just declare constants and functions to actually go in and calculate that in our computational model. And this is it continued. And the results page gives us a differing value at the 45-degree angle of 5.74 e negative 6, 1.72 e negative 5. And revisiting that, that is different than when we measured from our Excel and the equation data, but that was to be expected. And the x component was off by an order of magnitude, but the y component was not. Additional questions. What if we hadn't oriented the experiment to compensate for the magnetic north and instead laid out the meter stick at some intermediate level? The measured magnetic field would account for both the field from the magnet and the field from magnetic north of Earth, since we aren't orienting it to be equal to 0, and we would have gotten different results, and they would have been further from the true values. What if we were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The magnetic field due to the two magnets would be larger than the magnetic field due to just one magnet, and the directions would stay the same, but we could expect the magnitude of the magnetic field to double. The distances measured would be smaller as well. And that's the end of this lab.